Right, this is the first episode of Drinking with the Stars. Today we have a great guest. He's from UIC. He's a professor of ecological studies. Dude, what's the banana doing up there? That has nothing to do with this. Seriously, take down the banana. What are you doing? Put up the word ecology. All right, is that it? No, that's not even spelled right, dude. Are you ready to go? Where's the particle bands? Oh yeah, they're doing good over there. Particles, live it up. Anyways, okay, I gotta be professional now. This is my first real guest, and I don't know if I'll have another one after this. Today our drink of choice by Professor Orlando will be Bailey's Minis. Professor Orlando, can we give it up for him? Thank you. Thank you, loud clapper in the back. Thank you.
Hi, Joe.
Hi, nice to see you. It's a pleasure. It's a pleasure to have you here.
Pleasure to be here.
You're my first real interview.
Yeah.
And I've been doing a lot of research. I have a whole Bible of you.
All right.
Right here.
All right.
Okay. And I was reading this abstract, and let me tell you, first of all, I'm an educated human being. I have a degree almost in English literature, English writing. I read the beginning of this, and in the abstract now I read that you gave me, I have to say, I feel I've never felt as though my brain was so we're going to start off with basic words.
Must be a bad job.
Oh man.
Conveying the information.
No, I think it's me. I shouldn't, I shouldn't read under the influence. Let's start off with the basic premise here, which is adding psychological constraints to simple consumer resource models to see what happens to ecological communities. Now, did you get that? All right, put that up there.
Physiological constraints?
Did I say physiological constraints?
You said psychological constraints.
In all sincerity, you're a psychologist. You're an ecologist, and I want to start off with what is an ecologist, and maybe we can get some service around here. Is there anyone serving us tonight, or is there any? I'm sorry, I told you I'd get you some drinks, and I don't have anybody. Is anybody coming in?
Do you want me to just get them?
No. I got a guy.
I can do it.
You want to do it?
It'll cost you 25 cents.
I got no money right now. Hold on. No, man, no, don't pay. I got it.
I got a quarter here.
Thank you. Okay. We'll just get that later. Oh, there it is. There's one. Coming right out of the screen. There it is. I got it. There it is. Magic a quarter. There it goes.
Thank you. All right, how much would you like?
I don't know. Just maybe.
No. Just open up.
No, we got glasses and such for these guests. We don't want
It's
to
not
be
that
rude.
bad. It smells like coffee.
No, don't drink it all though. You're my camera guy. I don't even have my server. I mean, seriously, this is terrible. I have no.
Can I take a sip?
Yeah, you can try. I mean, but can you get me a freshman though for our guest? I mean, this is kind of rude, Okay.
Who cares about that?
Okay. How is it? Was it delightful? Well, there goes my camera guy. Well, this is your favorite.
Thank you very much.
All right.
Wow, that looks nice.
It's gonna be good.
Wow, that got creamy.
Bailey's Minis. Bailey's Minis. If you're drinking without it, then you're not a real scientist. So let's start off with the basics now.
What's ecology?
What's ecology?
So ecology is the study of organisms and their interaction with the environment.
I saw some of your Wikipedia work, and some people say, hey, Wikipedia isn't factual. But I read your stuff, and I'm not sure if it's still there, but
Some of it is.
some of it, yeah. So that's pretty real then. Looking at, you start off with crayfish? Crayfish?
Mm-hmm.
Okay. And then from there you evolved, and that was at the prairies in
The
Mills? Glenview.
Yeah.
That was Glenview.
Yeah.
There's prairies in Glenview. The only
James Woodward
prairie. What is it?
James Woodward Prairie.
Okay. And that's the only prairie left in the universe.
In the universe?
In Illinois, or in that area. That's the only preserved
Yeah, it's
prairie.
definitely
Wow.
in that area.
And who
It's right. It's got a McDonald's next to it.
Yeah.
It's got roads. That's Milwaukee and something else.
It's Milwaukee and there's golf around there. You went to school originally as a human being, and you said, "I'm going to go and I'm going to study crayfish." Did you think that when you were a kid? Did you think I'm going to go and study crayfish, or how'd you get there?
No, as a kid, I wanted to study lizards
Mm-hmm.
because I was just a boy, you know.
Yeah.
How boys are into lizards, you know.
Yeah.
And so, yeah, I think I always wanted to go into herpetology, but I never did.
Herpetology?
Yeah.
Herpetology?
Herpetology.
Herpetology, lizards.
Lizards, yeah.
Yeah, lizards and
snakes,
such. Snakes?
Yeah.
Yeah.
Turtles.
Amphibians. Is it the same field?
No, I don't think amphibians are included.
No.
I don't know what that would be.
No, that's frogs. Reptiles are.
Lizards, snakes, turtles.
Gotcha. And the word you said?
What did I say?
Herpetologist? Herpetologist?
Herpetology.
Herpetology. Those are some big words.
Yeah.
Let's put those words up there. Herpetology. How do you spell that? So now we got ecology again. Define it.
Define ecology
Yeah,
again.
say it again for everybody. So organisms are interacting with the environment. You start off with crayfish over in Glenview. And these crayfish, they're doing their thing in life, and then they're predators, right? Is that what they are? Or are they a predator species? Omnivores? Okay. And I remember you did this is before it, now you go way beyond just ecological studies now. You're going into bigger theories now from where you're at. And this is something that, when I read your abstract, I really apologize, because I was reading it, and I don't know what was going on until I read the middle part.
Yeah.
And such, because it defined the words. But if a regular human being is reading a scientific abstract, just even as an English major, if you don't know those words, you got to go look up a lot of words.
Yeah.
And I've read physics before, and I've understood basics. I don't understand anything about equations for the most part, you know.
Yeah.
But if you give me a basic equation, I mean, like now you're doing models, right?
Yeah.
So where did you go from crayfish, centipedes, you do your cancer research, you do we're hiding that, and then you do you're doing also models on, what was that last thing?
Yeah, so
evolve me.
So when I was when I entered school as an undergraduate, I knew I wanted to be an ecologist. So I emailed some professors, you know, to do some work in ecology, but at the same time I had to finish my degree, and I was always good at math, and I always really liked math. It's one of the only classes that I did good in, like in high school and stuff. And so so I took a lot of math classes while I was doing my biology major, and I was working on these extracurricular type of projects like the crayfish and the centipedes and whatnot. And then when I went to graduate school, I was going to go to graduate school to work on centipede ecology, and it was going to be all empirical and whatnot. But I always knew that mathematical modeling was super cool, but I didn't really know what it was. I was never really exposed to it.
What is mathematical modeling?
What is mathematical modeling? You would express some type of system mathematically.
Show me a basic system
You can
and
study it.
define it. Yeah. Can you define it like, you know, with your finger? Like some kind of system? Give me a visual graphic of this system. Maybe start with, can we use the crayfish as an example of modeling?
Yeah, so, you know, classic modeling started in ecology and evolution probably with, like, we were talking about the VOLTERRA model.
That's the beginning model in ecological studies.
Beginning model. So there was a little bit of population modeling before that,
which began with, what's the name?
Malthus?
That was in MacArthur, I'm sorry?
No, MacArthur's like 60s.
60s, okay.
Yeah.
So the beginning is Malthus.
Yeah, this is like inspired Darwin in like 1700s.
Okay.
Yeah.
Malthus is the beginning.
Yeah, yeah.
Okay.
He did an essay on population growth, and I think he basically said, when was that? I think he was, I don't know if he was in the 1700s or 1800s, before Darwin. Or maybe
Okay.
at similar times with Darwin. But he basically, I'm not sure how mathematical this was, but basically he said that because, population growth is exponential, that we're going to be fucked in the future.
Say we can just go to another planet and exploit that. And doesn't that kind of ruin all your theories? Because we just go to the next planet, right? Can you enunciate those words again? Because I can't.
Predator-prey model?
No, the word,
LOTKA, VOLTERRA. LOTKA, VOLTERRA.
LOTKA, VOLTERRA.
Yeah.
LOTKA?
Yeah,
VOLTERRA.
LOTKA.
I have a picture of them.
Okay. Well, there's two guys, LOTKA and there's VOLTERRA.
Yeah, I have a picture of LOTKA and
VOLTERRA.
VOLTERRA.
Yeah.
They're going to be the first of a series. I want to let you know. And we're going to take a picture.
And I don't think they actually knew each other.
No, but they put them back. Weren't
Just
they
one
in
of
the
those,
same?
it's like Darwin and Wallace. It's just one of those instances where they came up with the same thing at the same time, so they're both credited with the idea. So basically, the idea is you can have a predator and prey model, just because population growth is so mathematical. So like, imagine a bacteria splitting, and then those guys split. It's pretty easy to describe mathematically, population growth. And then having systems, population systems where species are interacting, like a predator-prey relationship is pretty relatively easy to describe as well. You just, have one species eating another. And these are the equations, LOTKA-VOLTERRA equations.
Okay.
Yeah.
But they're just all, you can generalize from a basic system such as the crayfish even, right? Is a predator-prey model.
Sure. Yeah, consumer resource model, in a more general sense. Yeah.
But consumer resource model, that's human now we're talking about. Right?
No.
Oh, see, when you say
Talking about
consumer,
ecology.
I think economics.
Yeah. Yeah, but who are the fundamental consumers? Who are the original consumers?
Everything.
These species, yeah.
Everything.
The original consumers.
Anything consumes, right?
Yeah.
Anything living consumes.
Yeah.
I think.
Yeah.
Like cells, they consume, right?
Mm-hmm.
Everything needs to consume something to survive, right?
Yeah. There's metabolic costs to keep things running, and then costs of growth and reproduction and all that.
And what's the smallest system you worked on now so far? Because you worked on smaller than crayfish over your own evolution.
Well, actually, right now we're working with these TETRAHYMENA VORAX.
Okay, hold on. TETRAHYMENA VORAX.
Mm-hmm.
Now they sound pretty cool. Are they from another
They're
planet?
super
Do they
cool.
suck your? Are they the things in like Star Trek? They come, they get inside you.
Well, they're single-celled ciliates.
Yeah, they're totally like that. Yeah, I don't know. We'll put a picture there.
So they're eukaryotes, right? So they have all the organelles and all that stuff.
Okay.
With being a eukaryote. And they're little aquatic species that are a single cell. And they're ciliates, which means that they have a bunch of little hairs surrounding their cell, and that they undulate, and that helps them swim, right? So they're this little, most basic sort of organisms. You think, well, not as basic as bacteria. One step up from bacteria, and then they can just sort of swim around in the water and consume things. But what's really cool about the TETRAHYMENA VORAX is that they are what we call a Jekyll and Hyde species. So they can switch from being a filter-feeding bacteriivore to transforming into a monster that feeds on other ciliates. And so basically, it reorganizes its whole sort of body plan, even though it's just basically a sphere.
And how
But
big
it has a
is this sphere?
filter-feeding sort of
This
model.
is like nano. We're talking about electron microscope small.
Yeah, but you can see them pretty good, like at 100x.
100x
You can
on a
see them
microscope.
pretty good. There'll be a bunch of little sort of tiny guys. I guess if you're at 100x, you could probably, see a few hundred of them. But you
Okay.
can see them sort of swimming around and stuff. Yeah.
And then they're feeding.
So they're a lot
off of-
larger than bacteria. They're way bigger than bacteria.
And what kind of system would they be in? They're not in our bodies. They're in.
could potentially infect our bodies, but they are in, in aquatic systems. So
Aquatic systems.
puddles outside and stuff.
Puddles.
Yeah, streams, lakes.
Anywhere.
Yeah.
Anywhere. And then where do they
So I don't know exactly where this exact species would be found, where you'd find this exact species, but TETRAHYMENA and ciliates in general, you'd find in aquatic systems, yeah.
But they can come from a bird's wing and such. And how ancient are they? These
Super ancient.
super ancient?
Super ancient.
Like trilobites?
Probably a lot more ancient than trilobites.
Wow.
The species itself, well, so they're single-celled. So
Yeah.
these ciliates, probably evolved shortly after bacteria and stuff evolved.
Oh, we're talking a long time
This
ago.
is a long time ago. Yeah. These
Wow.
are simple organisms. These things are just one cell. They
Yeah.
swim around. Yeah.
Wow. And how do you get your students engaged?
Students
Like with all this,
engaged?
do they come in, like say you got a regular 101 class, you deal with 101 classes now?
Not anymore.
No, but when you did, was that harder to keep kids engaged than say like the ones that are more engaged later on?
No. They're all pretty much, students. All they want to do is text and shit.
So, yeah, I mean, I don't.
Most of them don't care about.
Yeah,
They all want to be doctors, so most of them don't care about science,
that's that.
really.
Well, some do. There's a
Some
kid
do.
there.
Some do, yeah.
There's an occasional.
There's an occasional.
Yeah, yeah. But maybe, I mean, but for future scientists, and regular people out there that want to know, how can I become a scientist? How can I become an ecologist? Where do you start? What do you do?
Well, I guess it depends on do you want a PhD?
I don't know. Some people might want money. Now again, I went back to the specs here because I did a lot of notes. I was a big researcher,
Sure.
Now I want to just point out some factoids here that I researched because I've been doing a lot of research.
Okay.
Your entry-level salary, kids, boys and girls,
Don't be intelligent.
$29,920. That's $29,920. I make almost that now selling fitness equipment. Now, don't do this for the money because you're not going to make any. Let me tell you, but the average salary that I found, and these are all numbers that are just on this online.
Mm-hmm.
I don't know which site to give a reference to, but the average salary is $47,600. That's your average salary. Your maximum, but this is wrong because you told me professors are making more than this. Is $78,200. Who knows how old or new this is? But say you publish, the university needs you more because you're bringing in the big bucks, the big kids, the big money.
Mm-hmm.
The big money. You probably make almost 100 G's then. You
Well,
can
there's
be
also people using ecology for business. They have their own consulting firms and stuff like that. And I imagine they can make quite a bit of money.
Yeah, or working for the government, doing something.
Yeah.
And then when you get involved with the game theory parts, right, those are advanced theoretical formulas used for not only the ecological level, but also you can apply that to anything in the world, right? Or would you?
You apply game theory to I don't know if you can apply it to anything in the world.
Oh yeah. Well, to the stock, not the stock market, but to everything that what is the game theory then? You're working on that too? What is the definition of that? That sounds cool.
So, game theory is a modeling approach to modeling games, and so you have a game whenever your best strategy depends on what everybody else is doing, everybody else's strategy, or somebody else's strategy. Okay.
Your strategy.
Your best strategy depends on what others are doing.
So everyone's working together copiously then. It's
No,
not like Monopoly.
No, if you're trying to fuck each other over, it depends on what the payoff is.
Yeah.
Depends on what the rules of the game are, what the structure is.
Well, the rules apply based on the type of animal or such thing that you're focusing on, right? The rules are based on that game and that system.
What I study is evolutionary game theory.
Evolutionary game theory.
And the structure of those games is pretty straightforward. Your payoffs are fitness, right? So we formulate it as an evolutionary game. Your payoffs are fitness, right? The players are individuals of the species, right?
Mhm.
The strategies that you play are inherited, so they're heritable. So you just get your strategy from your mom or dad. So my strategy might be that I have brown hair and that I'm 5'7" tall.
That's a
It's
strategy?
part of my strategy. It's an evolution. It's an inherited.
But it's not a
sort of
mental strategy. It's part of your evolutionary.
Yeah, yeah. It's the evolutionary games, you know.
But the strategery advances beyond that, though, for human beings. I mean, we got so many layers of strategery.
Yeah, and then we talking about later. Oh, yeah, sure. Yeah.
But if you're talking about it,
Yeah, so the strategery can be very complicated, very complex.
Yeah.
And so it's underwritten by all our genes, and we got like 70,000 billion genes or something.
yeah.
And so
And then,
the strategy set can be pretty complex.
wow.
Well, I mean, what you see, because natural selection is operating, what you see, the variation you see in humans, you might say there's a lot of variation, but that's only very little of the variation that's sort of possible, right? We know if we just change our genes less than 1%, right? Is it less than 1%?
Yeah,
We'd
somewhere in
be
there.
a chimpanzee
Oh, it could be, yeah.
or something like that.
It's somewhere in there.
Yeah.
It's
So our
somewhere.
strategy set's huge if we play with what we have to play with,
Wow. That's crazy.
Yeah, but we don't see all that because we're under natural selection.
Yeah.
So there's only
so much you can see.
It's sculpted.
Yeah.
The strategy set is sculpted to something that's sort of optimal.
Wow.
Yeah. And those are the solutions to the game. That would be the solution to the game. And so that would be like, looking at a rabbit. Why does a rabbit have long ears, and why does a rabbit have jumping feet and fur? Because that's the solution to the evolutionary game.
But they apply this also to economics, too, right?
Yeah,
To
that's
see
where
how-
it came from.
This came from economics.
Yeah.
Who was the founder of that? That's not the... That's
Von
not
Neumann.
Huh?
Von Neumann.
That's von Neumann?
And Morgenstern.
So is that a scientist then? I mean, that's still ecological.
Von
It's not...
Neumann was a mathematician.
Oh, mathematical. So he came from...
And he did a whole bunch of shit.
Okay, so he came from mathematical.
Yeah, apparently he's like, I don't know when he died. I mean, he was alive in the 19th century. I mean, he was at Princeton, and he was a professor with Einstein.
Okay.
But he's sort of seen as the last, like, great genius in mathematics to live. Yeah.
Wow.
We're waiting for the next one.
We're still waiting.
Yeah, we're waiting.
That could be you.
No.
If you market yourself as a genius, you could probably sell yourself. Look at Hawkins. I mean,
Sure.
I mean, he's a smart guy, but
Yeah.
I don't believe everything he says. But I don't know,
Yeah.
I mean, if aliens come down, the last one he said, maybe they're going to destroy us.
Yeah.
I don't know.
He keeps saying, like, I'm doing all this math in my head, but who really knows,
Who knows what
Who
he's
really
doing?
knows?
But he's got a lot going for him, I mean, if I didn't have sex all day, I would be pretty goddamn smart. I think that's why I'm kind of... I don't even... Anyway, we can scratch that right now.
Scratch
Oh, we didn't even get to David Tillman? Wow. There's so much to go through.
What did you find here?
This is a consumer resource approach to community structure.
When's that from?
This one's from... oh,
That must be older stuff. That's nice.
yeah. You don't know you don't know anything about this stuff?
Oh, I know a lot about that stuff, but I don't know that particular paper. I know his book. He's got a really famous book from 1982, Community Structure, Competition in Community Structure.
David Tillman.
Yeah, it's all based on.
This is like, this is the badass. This is like your Rambo of, or your Brad Pitt of ecology, right? He's the main guy.
I guess, yeah. I mean, well.
I mean, if he was...
Yeah, I mean, everybody knows who he is. So his earlier work inspires a lot of what I do.
Oh, so...
His consumer resource modeling, yeah.
So David Tillman he's a hero of some sorts.
I guess, yeah.
To many.
I guess he could be.
Yeah. I mean, he's a hero.
See.
To some. I don't know, I think we've done some good stuff. We didn't really talk about, let me look through my notes here, I'm trying to be, stoichiometry. Stoichiometry?
Stoichiometry, yeah.
I was rehearsing that in the beginning. Does that fit in anywhere where we are? We're not even close to that point yet, right? Is that your last?
Where we are?
Your last theories are basically, how much time? What are we on in time here? Well, we should go to the science question of the week. This comes from some kid in, I think it's Michigan, and he asked, hold on, let me find his question. I got a question of the...
I got it. What's the evolution of the fart?
The evolution of the fart.
Actually, how'd you
Am I
know
supposed to
that?
answer that?
Yeah, it was from Bill Servino. He's 12 years old, and he's in Michigan.
Okay.
Sioux City, Michigan.
Okay. Well, I guess I don't know exactly what a fart is, but I figured that it's.
Think about the model.
Well, no, I figured that it's gas. So we have bacterial communities in our gut. I figured that it's gas produced by bacteria, and when you get this buildup of gas, but I don't know what the gas is actually made out of.
Some kind of stomach juices that form air.
What would be actually the chemistry of the gas? I don't know.
Yeah, but there's living things in there. The bacteria are definitely a part of this,
Yeah,
probably.
but as far as the evolution of the fart, I guess so. Sort of, it's some
Wherever.
sort of metabolism, some sort of
Yeah, but the metabolism itself would be the evolution, right?
breakdown of something that's the waste product.
And it's in animals that are
Some
any
sort of
animal with
metabolic pathway.
a gut with a what do you call this system here? You got the stomach, you got the intestines.
Yeah.
You know, anyone with those systems would have to have the farting capability. Because I don't think that. Well, I mean, I don't think that.
Microbes don't fart, do they?
No, I don't think I can't. I don't know. Well, look at like cells. Do they fart?
Do cells fart?
Yeah. Think about it.
Well, I assume that they could possibly build up a bunch of gas.
Bill in Michigan, we appreciate your question and thank you for
It's not an expert on farts.
sending in your comment via YouTube. I'll have to get a picture of you and put it up
I'll
there.
look it up. You should have given me that question beforehand. That would have come all prepared.
I'm sorry. Well, this is on the
Yeah.
spot.
So do you want me to tell you what my abstract's about?
Yeah, I didn't even get to that. Yeah, well, I want to understand what your abstract's about, and we might actually. I think we're out of time though. I'm going to have to ask you next time.
All right.
But as we started off, we defined ecology. We figured out the how systems work. I think we understand that. We got through. What as far as from going from.
I think it'd be much better if I had like a pointer stick
Uh-huh.
and I had little pieces of paper that you can flip and I could
Oh.
point at things.
Well, those are right there. You just can't. You gotta.
Yeah, very
You gotta tell me what that
But
is.
I didn't
though.
know what was going to be there.
Well, it's whatever you want to be there.
Well, it's pretty hard if you can't see it to explain things, to explain graphs.
Well,
and
wherever
stuff.
you want to point. What do you want over there? Look at this. What's that?
I don't know.
That's an apple. That is an apple right there.
All right.
Yeah, right there.
Okay.
You see that?
Yeah,
That's an apple.
yeah,
Check out that. That's your graph.
yeah.
There's a graph right there.
Yeah.
Now check it out. Okay, there's the evolution of a graph. It went up. It went down. Okay, there's Pac-Man. Here he comes. Boom, 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 boom. Pac-Man right through there. What do you want? Give me I know you got those crazy. I want to know what this crazy symbol is.
Let's
You got this crazy 3 symbol everywhere. I don't know what that 3 symbol is.
What's the 3 symbol?
I gotta go through your stuff, man. This is professional here. Hold on a minute. Let's
You
get to
mean
the
an actual manuscript.
Oh my god, this thing is crazy. We'll get to your abstract next time, but I do want to know. I want to know what's going on here. Like these numbers, okay? You
Yeah.
got a little 3, like a backwards
It's a
3.
sum symbol.
Huh?
That's a sum symbol.
The sum symbol? Oh my god. Kids would know what that is, man. That's a crazy symbol. Like you said, I think there's a convenience, and I don't know if you had a convenience in there, but our convenience would be junk food or whatever economically is sound, like Taco Bell, or whatever is fast food or fast, and I seen that. I don't know if you put that in there, but there was something like that.
The convenience.
It was
each
convenience,
one?
yeah.
Convenience.
Yeah, you have a convenience. I did read that. I can read.
Then we add the constraint of mass balance.
Okay.
So the consumer's fitness, so their per capita growth rate is constrained by the ratios of elements that they eat from their food. okay? And
Okay.
then they have different foods in the environment that contain different ratios of elements, and so they need to balance their intake of those foods, otherwise they'll lose out in fitness, and so that's where the optimal foraging theory comes in.
No, you visualizing. When you're doing these equations, when you're making a model, like what are you visualizing? Are you visualizing lizards and cockroaches? I'm just curious, because I need personally, just to make these things happen. Because in mathematics, when I was a kid, here was my big problem. I'm going to tell you. My problem was I couldn't visualize anything. They have like, I couldn't relate. It's like Bill goes to the store, he buys 3 apples. I don't give a fuck about Bill. I don't know who he is. I want to know about something cool, you know. If I could relate to that as a person in my brain, I could become a scientist. But when you tell me about Bill and apples, I don't give a fuck about apples. I don't give a fuck about Bill. I got a problem then I can't do the homework.
It probably doesn't apply too well to herbivores.
Sure.
Because plants tend to be very plastic in their elemental ratios, because plants have vacuoles, and so they can basically store a lot of nitrogen or a lot of phosphorus and whatnot, and this can completely change their elemental ratios. So plant quality just fluctuates quite a bit. But like animal quality is pretty fixed. Animal quality doesn't really fluctuate. So like our elemental ratios, the only way we can really fluctuate our elemental ratios is if we get like super fat, then we could be really sort of carbon-based. If I was like this fat, I could be pretty carbon-based, right?
Carbon-based.
So the model here, just for simplicity, assumes that elemental ratios for the resources remain fixed. Yeah. So where it might apply is at higher trophic levels. So, you know, lizards eating bugs, eating other bugs, spiders, you know, eating small bugs, things like that might be a good place to apply it.
And that could be under a rock. That could be as small
Could
as
be under a rock.
Hi there, my name is Jason Page. I'm normally the camera guy. This is Meeting with the Stars, and I'm going to interview the host, who's going to be the host for Meeting with the Stars. Joe, what inspires you?
Inspires me in life, or?
Yeah. Well, what inspires you to get up in the morning?
Wow, that's a good question. You know, I gum my mouth all the time. That's very unprofessional, you know. I hope no one's seen that. I was trying to suck on it.
Okay, Joe, why do you like to chew gum?
I hate chewing gum. I just brought it so I would smell nice when I interviewed today, because I tried to be very professional. I mean, I think this went well.
Yeah?
For the first interview. You know, it had some flaws. We had some kinks. I realized that, you know, I have a lot of work to do, you know.
Where should you put that energy? In what aspect? I mean, where do you need to work more to make this better?
Probably have to be a little bit more educated on what the hell is going on.
And what is going on?
I really don't know what's going on. Ecology is an interesting field. It's not something I really focused on in my life. And
Let me ask you, what interests you?
what interests me?
Yeah.
What interests me? In life?
Nanotechnology.
Oh yeah, that's true. He's got
Time
me.
travel.
No. Time travel and nanotechnology would be, yeah.
What do you know about nanotechnology?
You know, I know they're little, tiny little robotic, you know, things. And basically with robots, you know.
What's the eventual goal of nanotechnology?
Oh, you can rebuild organs, you can rebuild everything. The only thing is you gotta get to the point where you can actually download your memory so you can actually use it.
Now, do the nanotechnology, do they rebuild the organs themselves, or do they become the organs?
The little robots, you know, I thought they rebuild, like, they make things, like, genetically. That's what I
Okay.
pictured.
And what is genetics? How do they do it genetically?
You know, you take the information, I think you're using programming, you know, and you're getting the genetic coding, and then you're using that coding, like you use regular coding.
And what's programming?
Programming would be the basic, any language that whatever language they decide to come up with, to design for that, you know, language to create the...
And what is language?
Language can start off as a sound. It really is arbitrary to the community that it's based on.
And what is sound?
Sound is out of your vocal cords or whatever else produces sound. A tapping noise, and such things like that.
Yeah, but what is it actually? What is the
Oh.
essence of sound?
You know, it's waves.
What are waves?
Waves. I think we're going to get down to particles eventually, so I might as well sum it up to atomic matter.
What's the relationship between waves and particles?
Particles and waves, you know, that's a good question. You got waves, you got particles. Can particles hang out on waves? I don't know, like surfers? Can they hang out on surfing waves? What do you do? What happens with particles and waves?
What inspires a surfer?
Probably the same thing that inspires everyone else, you know. Something to do.
So let me get back to the first question. What inspires you?
You know, I'm just inspired by, what am I inspired by? I'm inspired by others that do great things, whatever that is that they like to do.
Beautiful.
That's it. Yeah. And that's it for this week of Drinking with the Stars.
So, what do you do for a living?
Sticky foot.
And can you elaborate on that? Can you elaborate on Stinky Foot?
That's funny because when I was a kid, we played Stinky Feet.
Yeah. Well, how do you play Stinky Feet? What?
I don't know. That was bad. That was a bad game. It's a bad game. It's scary.
this interview is going great.
Well, thank you.
So what's the next question?
Hey, I'm asking the questions here.
I'm sorry.
What's in your milk over there?
I don't know yet. Let me try.
Oh, your milk on the computer over there.
Oh, coffee.
Coffee in your milk.
Yeah.
It is sort of like coffee in your milk, huh?
Yeah. Well, the best part of the experience is you pour the milk in the coffee, and then you see galaxies form for about 5 seconds, and then everything disappears. There's no galaxies anymore. So I'm thinking in my mind that 5 seconds is five.
Special.
Five trillion years. We're living in that coffee milk relationship right now, as the milk's being poured into the coffee. So I'm thinking that eventually everything's going to be milky. You know, like a Milky Way, like
So,
flat.
Is the Milky Way just a giant coffee mug?
Uh,
Are we living
Yeah.
in a giant coffee mug? We're just a split second in a giant coffee mug.
yeah. It's like the theme park. You have milky coffee mugs all over the place, and they're all branched out and attached and spinning around in different ways.
Oh, they're spinning.
Yeah. I mean, galaxies spin around other galaxies, don't they?
I guess. Sure.
Either that, or they engulf other ones. Black holes, that is.
But is there a biggest coffee mug?
I mean, what causes them to rotate and flush down the hole? Black holes, right?
Black hole, sure.
Yeah. Just like you piss and flush.
Black hole. Excellent.
What's your next question?
Let me think of one. Let's do that, yes. So, what do you do here? What's your role here?
What I'm doing right now, being asked questions.
Being asked questions?
Yeah.
Okay. What's your favorite type of question?
I, with a
Aye.
question mark.
Okay. I.
Don't know.
You don't have an answer for that, huh? Answer for that. Okay. Well, let me see what kind of research I've got on you. Let's see here. It says you were discharged from the military about 6 years ago here.
Does it say honorably?
It says-
Let me cover that up right there.
It says dishonorably due to speech concerns.
Law? Speech concerns.
Yeah, it tells a dishonorable discharge due to speech concerns.
Sometimes my tongue goes in places they're not supposed to.
Oh. I figured maybe you were swearing too much.
Swearing?
Yeah.
I would never put a swear over an act.
What?
Huh?
Huh? I?
Aye. Yeah. That's the answer.
Well, it says here that your staff sergeant didn't approve of your behavior on September 20th. Do you care to elaborate on that?
What year was that?
October 2010.
Ah, yeah. October 2010. Was I born yet? Check my birth certificate. It's right over here. Birth certificate. What does that say?
Birth certificate. It says, nope, you weren't. It said 2015. So what were you doing in the Army before you were born? I didn't know that was possible either. What were you doing in the military before you were born?
I was going through cycles.
Ah.
Not like developmental cycles.
Sorry. It says here that part of the reason why your staff sergeant was so angry with you.
Oh, no. Oh.
So we were talking about developmental cycles.
Oh.
Yeah, yeah. What are those?
Those are cycles of development.
Okay, and so does that mean that you did
I was, this is before I was born. So like 15 years before I was born, I was developing.
Yeah.
You gotta ask the engineers, and a year after I was born, he decided to kick me out because of my tongue.
But since it's a cycle,
as it says right there, anyways.
but since it's a cycle, are you going to get there again?
If they put me back in the test tube,
Oh,
but
you boarded a test tube?
well, it would have to be a really big one if they put me back in.
But
And
no,
then
what
shrink
maybe
it, I
you
guess.
get big, then you start getting small again.
That would be reverse.
And then your mom eats you?
That would be reverse evolution. Thank you, son. Yeah, I got a kid now too.
Oh.
Naturally born.
What's your name, little boy? He plays beautiful music.
Joey.
That's a great name.
I haven't taught him linguistics yet, but he knows how to say I, right? That's the question, right? I. There you go. He said it.
I've heard he got a big crush on Mrs. Potato Head.
Who's Mrs. Oh,
Yeah,
that's
Mrs. Potato
that's my son's teacher.
Yeah.
Yeah, she was also his babysitter too.
Yeah. I heard he takes off the head of Mrs. Potato Head
Yeah.
and he sticks it in his ear.
He's got a wild imagination, but all I've ever told him is I. So I don't know where he gets all that from I.
Huh. Yeah.
That's a.
I heard he fills the body with spit then, and then he shakes it all around.
Who spit?
His own spit.
Oh, I don't know. You have spit in your mouth. Joey.
Hi.
Thank you. Okay, so I was ejected from the military.
Yeah.
This dishonorably because of my tongue.
Yeah.
Why did they create me? Does it say that there?
Why did they what?
Why was I born?
Oh, why were you born? I guess you were supposed to be like a cyborg guy, like a badass like cyborg soldier guy. Yeah, you're pretty strong. I mean.
I know the answer. You were once a beautiful cyborg boy that became a man 15 years ago. 15 years ago, Daddy, you were a cyborg man. 15 years ago.
Do you have any cyborg in you, Joey?
Hi.
He must have if I naturally produced him.
Did you naturally produce him?
Yeah, without a woman.
Oh, wow.
I
Just you in a test tube?
No, it came out of my own tube.
Oh. Self-fertilization.
Exactly.
Cyborg self-fertilization. Cyborg self-fertilization.
I heard you could get a kit for that at Walgreens.
That That's why they created me.
Is it?
I was the test
Oh.
for that to go to market. That's how the government makes money anyways.
It was obviously very successful.
Right after sea monkeys, there was human and cyborgs. Then
And now they have a kit at Walgreens.
Yes, they do.
And, you know, the government gets money from corporations, and corporations get money from us. The government sees that, so they...
This concludes this interview.
Yep.
That's
Thank you,
it?
Dr. Nothing. Yes.
I was called Dr. Nothing? They called me Dr. Nothing?
Isn't that your name?
They gave me nothing. No name.
You're Dr. Nothing.
I know I'm a doctor, but I'm nothing.
You're Dr. Nothing. You just have to Dr. Nothing. You see, just put them together. Dr. Nothing. Dr. Nothing. Dr. Nothing.
I got it.
You got it.
Thank you.
All right.
I'm Dr. Nothing. And you are?
Nick, who am I?
Dr. Nothing version 2?
Sure.
V2.
Yes.
No, actually, you're, my son is version 2, actually.
Yeah. I can be
That's
version
future you.
You are a humanoid, right?
It's future you.
three. I think so.
Okay. Am I a humanoid?
You're cyborgian.
Cyborgian, what's that?
Well, that's
Maybe I should do that with all my interviews. Give the longest handshake in the world. Let me give you a handshake.
I believe that's part of robot.
Why are you holding
Part
my
human.
hand and shaking it?
Oh, I thought you were holding my hand and shaking it. Good day, sir.
Good day, sir.
This matches the table nicely.
Yeah, I like how that matches the match.
Now we do exit walk.
Boop, boop, beep, boop, beep, boop, beep, boop, beep, boop, beep, boop.
Okay, that went all right.
Then
Now we just got to figure out which of the three to use for the show.
cut those down.